Today we'll be talking about diodes, some type of diodes, and how they work. So basically, first of all, a diode is an electric component made of a semiconductor, typically made of silicon crystals, that can be modified to change its conductivity properties. So first of all, a diode is composed by two different types of silicon material. We have a P region and an N region. So these are two silicon pieces doped with a little bit of impurities to change its properties. So in the case of the P region, this will have a lack of electrons, and in the contrary, the N zone will have an excess of electrons. So when these two neutral, in the first instance, neutral pieces of silicon are attached, they interact with each other. The P part takes electrons from the N part, creating here what they call a depletion zone. In this depletion zone, we will have an excess here of negative charges and an excess of positive charges. This basically means that when we put a power supply here, a voltage supply here, these electrons will go gladly will be attracted to the P part where there's a lack of electrons, creating a flow of electrons, and this will be creating a current going in the opposite direction. So this basically means that the diode will only let current flow in only one direction. If electrons from the P part that have been taken from the N part try to go back, they will not be able to do that because of the depletion zone. There are charges here that repel them, and that only lets current flow in one direction. So that's the main purpose of the diode. It lets current flow and conduct in only one direction and not the other. So taking this into account, a diode will be represented like this. The arrow representing the direction of the current flowing, and this wall here representing the barrier that doesn't let any current flow. You show right there. So knowing what the diode does, we can talk about the behavior of the diode. So in an ideal way, ideally the diode will relate its voltage and its current in the following way: having zero current conducting when the voltage supply is negative and it doesn't conduct, and when the voltage supply is positive, it will conduct, and it would let the current flow all the way up. This would be the ideal behavior of a diode. However, in reality, this is not ideal. So this is not perfect. So the current will tend to do this, to curve its way up, and it will have a little bit of leakage current when the voltage supply is negative. So around here, the diode's voltage, the voltage that the diode is experimenting, will be around 0.7 volts. Now, taking into account how the diode works and how it's made, we will explore two type of diodes, and we will be watching their behavior. Okay, so the first type of diode that we're going to have a look at here is the TVS diode, or transient voltage suppressor. Basically, this is a type of diode that its purpose is to protect, serve as protection for other circuits. It will not let high voltages or high currents get into the circuit, that because those changes may damage the circuit or the components that compose them. So the main characteristics of this diode are its low capacitance, its low leakage current, and its fast response. This means that the diode will have a low clamping voltage response in response to high voltages. So right here in this circuit composed by an alternate voltage source, a resistance, normal resistance, a circuit, it could be any circuit, and the diode with the reference node, we have here that this diode will always be experimenting three main stages. The first one being the reverse standoff voltage, in which the voltage here will be low enough to produce small currents that will get into the circuit as normal. And in this case, the diode will not be activated, let's say, because it will not conduct. But when the alternate voltage rises, reaching a high voltage level, it will produce a higher current. This will be detected by the TVS diode, and it will enter into a breakdown voltage, in which it will start conducting these high voltages, while the small voltages will continue to flow over the normal other circuit. So now we enter into the final stage, which is the clamping voltage, in which the diode will conduct these great amounts of current, and it will clamp them, producing a lower or constant voltage value. Now, taking this into account, I will show you the comparison between the input voltage and the output voltage. Let's say we have an input voltage that goes from here to there, like this, like a normal sinusoidal wave. We have a B max, and a negative version of that. So in this case, the effect that will be produced by the diode will be this. It will reach a maximum voltage, and then it will clamp it, and it would not let any negative voltages enter the main circuit, right? I'm sorry. Here's again like this. It will cause this effect. This is the clamping effect. You could put this is right. This is true for an unidirectional type of TVS diode. The TVS diode can also be configured in this way to create a bidirectional TVS diode that will only change this behavior, making it possible to enter negative voltages and clamping them also.
Okay, Now I will talk about photodiodes. Okay, so the many difference between photodiode and conventional diode is that they use reverse polarity. As we can see below. Okay, in the regional with the larger number of holes, there is a window designated for the entry of light waves. Okay, the input of light gives the electrons enough energy to move. Uh, as we can see below. Okay, in the complete darkness, the photodiode behaves like a conventional diode, and this is a reflection in the photodiode graph. And we can see below in the graph the line yellow is the graph of diode conventional. Okay. However, there is a small current lag. This lag will be larger each time more photodiodes photons enter. This laker current induced to reserve bees. Okay. Mm, this is so current lake. Okay. The photodiodes are generally is used as sensors in smoke and fire detectors, remote controls, and lighting. Okay, photodiodes are also used in various medical applications. Mm, so, so. Um, so sorry for the right in the application. Um, advantage, advantage, low noise, low cost, and this is compact and light. Um, this is this have long life, high quantum efficiency. This device, um, this bench, um, this is a small R. This have much low sensitive and response time is low. And this is the the end of photodiodes. Thanks.